Hey, go ahead.
And we're back. Chapter 2 test hints number 17. We have artfully created some examples here. And our test hint says, write the chemical symbol of an element. These are all chemical symbols for elements. Okay?
Yes.
Some of them are just single individual letters, and some of them are multiple letters, well, two letters, like nickel and copper. And notice that there is a difference between C, capital O, and capital C, little o.
Yeah.
Okay.
It's important, and we've talked about this in our classes. One and only one letter in an element's symbol is capitalized.
Right.
This is inappropriate for the element chlorine.
No.
All the other chemists are going to point and laugh
Yeah,
as soon as you leave the room.
Right. Right.
It's
Maybe
you
even
use,
before you leave
yeah,
the room.
right. You use a lowercase when it's supposed to be lowercase. You use a capital when it's supposed to be capital. Right.
And I think they remembered a lot of this from their 9th grade class, so we're good. Okay, number 18, write the symbol for iron. Well, you're going to have a periodic table. The periodic table has the names of the elements on it. Find iron. We did a lab this week on iron. I bet you have seen and written the symbol for iron numerous times the week of this test. So, yeah. You can figure that out.
Number 19, identify a chemical property. Now, this goes back to that earlier batch of questions.
Right.
Of course, if you're paying attention to the test while you're taking the test,
Oh, yeah.
sometimes you can go back and kind of jog your memory on whatever question number 4 was about. Might be related to question number 21.
Yeah, because number 4 might give the definition of
Right.
something that you're trying to find an example
Right.
of later on. We actually have a whole string of questions here. I see 19 through
Right.
23, well, 20 through 23. We're going to be talking about chemical changes versus physical changes. But again, a chemical property has to do with reactivity. So behavior of a substance in the presence of another one. Does it react with it? Does it not react with it? Does it sort of a little bit react with it? It all goes down to changing it at the atomic molecular level. And then in 20 through 23.
Right. There are some, this is a whole set of questions where, again, you need to read. We're pounding home the point
Right.
that the difference between physical changes and physical properties and chemical changes and chemical properties, you need to know the difference. It's a fundamental part of this course going all the way through the end of the year. So yes, it might sound like we're beating a dead horse, but there's a reason for that.
Okay, so this piece of glass here, if we broke it, that would be a physical change.
Yes.
If we melted it to reform it, yes.
The fact that it is brittle and will break
Yeah,
is a physical property.
physical property.
Right.
And even if we melted it and reformed it, that's still a physical change.
It's a change of state.
Right.
Melting
Now,
it, yeah.
This happens to be a piece of plate glass, but if we had glass in the shape of a beaker, the fact that it can be beaker shaped is physical, but the fact that that beaker can hold concentrated hydrochloric acid and it doesn't dissolve away, the beaker
Right.
itself,
Right.
means that that glass is not reactive with acid.
Right.
And the fact that it's not reactive is a chemical property of the glass.
Right. And that's important too.
Right.
Knowing that some things do not change, some things do not react, is just as important as some things that do.
And I see, glancing at these questions, because we actually happen to have the test in front of us while we're doing these hints, several of those,
Well, that's
they
why I
can
did
stop
that.
the
That's why I
camera, they can stop the tape and zoom in. And
They're not that motivated.
okay, so a lot of these are written in, which of the following is not, or all of the following except, which means, like Mr. Sustin said, read all the answer choices.
Read them all.
Okay, 24. Identify a chemical change that happens to a specific substance. And this will be a substance that we tested in lab.
Something you're familiar with.
Yes, and it was the physical chemical changes lab, so you should go back over that lab. And the answer choices are lots of different changes that can happen to this substance, but we're going to ask you for either which one is chemical or which one of these changes is physical.
Yeah.
So think about, again, is this changing the substance at the atomic molecular level, or is it just changing its size, shape, form, whatever, that would be physical.
Which is very similar to question number 25, identify a chemical property of a common substance.
Well, the hint says.
It says water.
Yeah.
It's a chemical property describing how one substance reacts with other substances. So again, read the question, stay focused on chemical properties versus physical properties,
Right.
stay focused.
And as you prep for this test, you probably should look at some of the additional resources we have posted and look at lots of different common everyday examples, because I do remember on this test, sometimes there is weeping and gnashing of teeth because people walk in very confident and they know the difference between chemical and physical, and then they start reading all of these answer choices that are the opposite and they get it mixed up. And then they start, after a certain question, they start answering all of them backwards, and it's very frustrating. And they, you know, we get the test back, and like, oh, I know this stuff. Why did I write that down? Because you can't rush through it. So I think that's one reason why we keep emphasizing that you really have to pay attention to what you're reading and doing.
26, describe the type of change that occurs during a common natural phenomenon.
It's
That
fall.
happens this time of year.
Oh, yes.
That's enough. Moving on.
Okay.
27.
27, identify the basic indicators of chemical change. So, how do we know that a new substance is forming? There could be a dramatic and exciting explosion.
Always a good one. This massive release of energy.
Right.
There could be a
Fire!
beautiful color change. Yes. Where two clear solutions would mix together and become yellow
Ooh, wow.
or something.
Because a precipitate forms, so a
Oh,
solid
yeah.
comes together.
The formation of a
Out
precipitate.
Right.
Fire. Or formation of a gas.
Oh, yeah.
Fizzing. The
Right.
high school word for fizzing is effervescing.
Oh, effervescing.
Yes.
But it's not just boiling. It's
No,
not,
no, yeah.
It's not the gaseous or vapor state of substance like water being released and boiling. This is a gas
A
that's
new
actually
gas
produced
that wasn't there.
at standard conditions from the substances that are reacting on electrical energy, like in a battery, sometimes mechanical energy.
Light energy, like a glow stick or something like that.
Right. So yeah, we had some examples
Sure.
of those in our video.
Right.
Okay, moving on.
28. 28?
Yep.
Yeah, 28. Identify a specific process that indicates a change in identity of a substance.
And this question will be giving you everyday examples, I mean, things that you might have had, and probably have had an experience with.
Yeah, but again, if you're paying attention to chemical changes change the identity of substances. So pick the one from the list that's a chemical change.
Right. Alrighty, 29. Apply the law of conservation of matter to a chemical reaction. Well, we know in the laws of conservation that matter is not created or destroyed, and that means our mass is going to be the same before and after.
Right.
And as long as we trap everything in a closed system, and we have not lost any matter during the reaction, even if it's an explosion, we would still have the same amount of stuff that when we're done that we put in.
Just like Morrison did in the video.
Oh yeah, the video. It was great. In the box with the penguins and the firecrackers and stuff.
30. Apply the law of conservation of mass to a chemical reaction. Well, again, mass is conserved.
Right.
If all of our matter is there
Right.
from the beginning to the end, matter has mass.
Mass, yeah.
So if all the matter's there, then so is all the mass.
Right.
Good.
Okay, 31. This is the last of our multiple choice.
Yes.
Use the law of conservation of mass to describe a specific process or change. So we're going to explain a change, and you have to tell us what happens in that particular situation. And when we come back, we will tell you all about the short answer questions.